we knew that we had to label millions of images, and therefore human labeling was out the window.
Welcome to Talking Autonomy. I'm joined today by Volkmar Uhlig, our CTO and co-founder here at Ghost. In our last session, we talked a little bit about KineticFlow, the core vision perception algorithm at Ghost. This is an algorithm that's built on a universal physics-based approach, and it delivers the object detection as well as distance perception and motion of all objects in a scene. But we didn't get a lot into how we build KineticFlow and ultimately how it's trained, because its universal perception allows a very different pipeline for model training. So Volkmar, why don't you walk us through a little bit about how we get the information necessary to build and train KineticFlow and what that pipeline looks like?
So KineticFlow ultimately is lots of objects in lots of places. And so the first step we do is we have a fleet of cars. They have our kit installed. And our kit not only can drive the car, but it can also record what's happening. And this is what we are doing whenever the car is active, cameras are rolling, and we can see the world. And so as we are driving around, we get stimuli from cars being close and cars being far, or pedestrians walking across the street, etc. So then we take all that data which is recorded, and we can easily produce thousands of hours of footage. And then we upload it into our data center. And then in the data center, we are then processing that data and segmenting it.
So our data center we call Ghost Train, our centralized training environment. But there we have a mixture of CPU machines, GPU machines, everything you need to basically tear down and label data correctly.
Mm-hmm. So we have a huge storage cluster, obviously, for storing all that video data. And we are recording at the highest fidelity of the camera, so that's a lot of data. And then we are taking those frame by frame apart, and then we are analyzing it for what are all the obstacles that are present in the scene. And this is where we don't use any human labeling. So this is the typical approach, like pick your pictures, send them to a labeling company usually, and then a couple of days later you get back the annotations, and so they are drawing bounding boxes around cars, or they're labeling road markers.
Is this what I'm doing with CAPTCHA every time I'm clicking on the CAPTCHA?
Yes, correct. So you're contributing to the understanding of the world.
All right, so I think I have a pretty good sense for what a traditional image-based AI company might do to label an image. They might go and circle, this is a bus, this is a traffic light, etc. What does a labeled image for Ghost look like?
When we are having a label, it tells us for every pixel in the scene what's the distance, and then distance expressed in disparity in a stereo pair. And then it is also how much the particular object moved. And so from those pieces of information, and there's an object here is in the broader sense a plane, which has similar physical properties in the scene. So it could be the side of a truck, or it could be the whole truck, depending on how far it is away and what the resolution is. And then with those annotations, we go into the training set. So now, usually what we want is a well-balanced training set so that the neural network can actually understand all the combinatorics. So we want objects which are close, and we want objects which are far and which move in different directions.
Right. So basically we spend a lot of time collecting data, getting in our data center, analyzing it with the really high-end, both stereo and mono computer vision algorithms to label it. And that creates a huge training repository for us. And so then we're able to basically pull from that repository whenever we want to train a network.
Yes. I think the key difference here is that our labelers are mathematicians. And so they are building algorithms which are annotating our images with exactly the information we want to make driving decisions. And then we just take all those images together and we're training a network.
And so when you're doing that, it sounds like it's important to make sure you have accurately labeled source images and also ground truth data sets to be able to test networks against. So how are we verifying that that's accurate?
So one is we can annotate more data. And so by doing that, you have your training set and you have a validation set, and then you have out of sample data sets. And so we can verify that our networks are actually picking up the right signals, and those signals are universal and not specific to the training set. But then on the flip side, we also have validation by using alternative sensors. So if we have a radar team and using radar data, we can say, is our depth estimation a good depth estimation? Is our velocity estimation a good velocity estimation? Because we have that secondary sensor we can compare it against.
All right, well, thank you. Very helpful. I mean, I think we've gotten a good sense here for the entire pipeline at Ghost, how we can go collect data, completely auto-label it without any human involvement, and bring it through our training process to train a variety of neural networks. Thanks, Volkmar.
Thank you.